Hi everyone, my name is Tim, and I'm from the Teller team, and I'm here today to talk about the next generation of the Teller Oracle. So first off, I'd like to tell a little story about a few years ago when I was with a friend of mine. We were watching the Kentucky Derby, which is a big horse race in the United States, and neither of us knew much about horse racing at the time, so we decided to make things more interesting. We both bet $20 on the outcome, and so I took the first half of the list of competitors, he took the bottom half, and in the end, I won the bet, but my friend didn't have $20 in his pocket at the time, and I figured he would pay me later, but that day never came. So we're not friends anymore. But anyways, a few years later, I got interested in Ethereum. I thought it was pretty magical how you could create these systems of rule enforcement where everyone has to stick to the rules of the game. No one can defect. And it seemed pretty incredible that you could create these protocols, games that anyone in the world can participate in, no matter if they're anonymous, if they're just random strangers on the internet. You can use distributed state machines, smart contracts, to layer new incentives on top of an existing flawed incentive mechanism from the real world. But there's a giant problem with chains like Ethereum. They're super limited. They only know about their own little deterministic world by default. So if you want to create protocols that depend on external data, you need to solve a problem. You need an oracle. And if you want to build credibly neutral, trustless protocols using things like Ethereum, with oracles, you need your oracle to be credibly neutral and trustless as well. So that leads us to the Teller Oracle, which aims to be trustless and decentralized. And so Teller's been live since 2019. It's gone through multiple iterations since then, but it basically works currently by having a staked set of data reporters, which anyone can stake and become a data reporter, and anyone can pay a dispute fee to dispute any data. And whoever wins the dispute wins the stake plus the dispute fee. So that creates a strong incentive to provide good data. It provides an incentive for people to monitor and validate all the data. And this data is secured optimistically. So that means that it takes a period of time to wait for disputes before data consumers can safely use the data. So as we, the Teller team, have worked in this Oracle space, we've thought about some ways that the Oracle can be improved. One item on this wish list is to have fast, robust data. So there's a certain set of users for whom data latency is a big issue, where their protocol cannot work if the data they have to use has to be 15 minutes old. And then on the other hand, there's a long tail of users that have very custom niche data types that they need. So we think an Oracle should be able to serve those use cases as well. And another point is that it seems we're in the multi-chain world now, so another chain is seemingly deployed every week. So more chains should not be a bottleneck for an Oracle. And finally, the Oracle should be able to achieve all of these objectives and more without compromising on decentralization and trustlessness. So that leads to the next generation of Teller, which is called Teller Layer. It's an L1 Cosmos SDK chain, and it works by aggregating together many reports from multiple reporters. It does this aggregation on chain. It still uses disputes to penalize malicious actors, and then we have this great L1 for aggregating, validating all this data. Then it needs to be useful to users, and we get it to those users by doing light client bridging. which we'll talk a little bit about. So as we built Layer, there have been some architectural questions, problems that we faced, one of which is who actually should report this data? We have an L1 Cosmos chain, so that follows that we have a staked set of validators already. They already have skin in the game. So that's one potential set of people that could do the data reporting. But a problem with that is that the Tendermint validator set is capped. And remember, we want our Oracle to be able to serve the niche data type, the very custom data type. So if say your validator set is 100 validators, and some user has a very custom data type that they want, they might not be able to convince any of those validators to support their custom data type, maybe their risky data type. So therefore, we chose to split reporting and validating into two separate roles. So the validators are concerned with the deterministic objective chain state, whereas the reporter role is concerned with validating, creating good external data, which includes a lot more subjectivity and not as much determinism. And this reporter set is not capped, it's boundless. So that means that if one of the existing reporters does not support some user's custom data type, that user could choose to go stake and become a reporter themselves, provide their own data, and they gain the security that Teller Layer provides. Another question is, where do the reporter stakes come from? They need to have skin in the game. So one potential place those stakes can come from is by forcing all users to choose between staking to reporters or validators. But we didn't like that solution. That would cause some competition between those two sets of roles, and that would mean that if someone chooses to stake to validators, the reporter set is less secure. An alternative solution would be to create another separate second token. But again, that seems to probably create some of the similar competition between the two roles. So we opted to use a dual delegation model. So validator stakes can be redelegated to the reporter set, which creates some capital efficiency in the system. And this type of restaking probably doesn't have some of the same drawbacks as other restaking. They're redelegating within a unified system. Reporters and validators on this chain have very intertwined interests. Now, on a separate topic, we have light client bridging. One of the reasons we chose Tendermint for our new Teller upgrade is that Tendermint is very light client friendly. So Tendermint consensus prioritizes finality over liveness. And that makes it easy for light clients to efficiently reason about, determine what the chain state is. And users can still use that light client method, like the base light client method of verifying 2/3 of validators signed a block header, and then using Merkle proofs to find your data within the chain state. But we took it a step further by creating these Oracle attestations. So with each data report, all validators sign just the data and some metadata. And so then users don't necessarily have to deal with the Merkle proofs, finding the specific Oracle data within the full chain state. So we think that's cleaner for users that are trying to bridge data. But again, we don't really care, Layer doesn't really care how users read the data. So users can choose one of these two options. They can create their own method. And getting in the weeds a little bit for those that might be interested, using Cosmos, we have a fairly new upgrade from Cosmos, or an ability called vote extensions. So that allows you to add extra work and logic for the validator set, and you can do that without directly editing the consensus mechanism itself. You add this on the application layer. Now, another problem with the light client bridge is that a light client has to be able to track, has to be aware of the validator set. So each time you update the validator set in the bridge contract, you're costing gas. And so we wanted to limit those gas costs in the bridge contract, so we created a threshold that under which you don't have to update the validator set in the light client. On a separate note, we created a 5% limit on how much the validator set can change within a 12-hour period, so that slows down the amount of validator set updating you have to do in the light client bridge. And also it has the added benefit that it slows down changes on our chain itself in the validator set to at least slow down some particular attacks. Another point is that us having an L1 gives us the ability to have social consensus as a final backstop of security for our whole protocol. So if the unfortunate situation arises where some malicious actor takes over 2/3 plus percent of our chain, we could always choose to fork our chain. All the good community members, good actors, can choose to go in the good direction and slash the bad actors. So that creates the ability to secure more value than even our whole market cap. But there's still a kind of an open question in that complete solution where we can do that perfect social consensus recovery, forking on our own chain. But then once you go over to the user chains where the light client bridge exists, that doesn't know about which correct fork to go with. So there's some interesting ideas, research out there about how to solve those problems, but I think that's outside of the scope of this talk. Another question we faced with creating teller layer was, how does data finality work? So remember, we want to create fast data. Some users depend on being able to consume some data immediately, which doesn't work for optimistic data. And so the way that we've added the ability to create fast data, to secure data quickly with teller layer, is that we do on-chain aggregation of many reports. So we take a median or mode depending on the use case. And that also means that there's potentially the whole chain stake backing a particular piece of data. So we consider that if 2/3 of the reporter set has contributed to a piece of data, that data is considered robust data, which can be consumed immediately without any dispute waiting period. So I should point out that all data reporting is optional. There is no activity leak, there's no penalty for failure to report data at any given time. And the reason for that is that we, as an Oracle, we're interfacing with the outside world where things are not deterministic, they're very subjective. APIs can go down, or we find edge cases and definitions that weren't accounted for. So you might argue that maybe in times of high uncertainty, no one should report any data, and Oracle consumers should handle those cases themselves. Continuing with the data finality, on the opposite side of fast data, we still have our optimistic data, which will likely cover more custom niche data types. These might be just very unpopular or less popular types of data that most people don't have access to finding the sources for, or they just don't have any interest in supporting this data type. It might be more risky data. But so we consider that if less than 2/3 of the reporter set contributes to an aggregate report, that's considered optimistic data. So in that case, users still build in a dispute waiting period to achieve probabilistic finality over a period of time. If no one disputes a piece of data, that's a strong indicator that the data is good. Yeah, I think I'm going faster live than I did on my own, but just to recap, Teller Layer has created some extra capabilities for the Teller Oracle. So first of all, we've achieved fast, robust data. We also still support very flexible data types. People can define their own data type, whatever they want, and they can become the reporter themselves for that data type if they want. With Teller Layer, more chains is not a bottleneck. So with current Teller, we're a set of contracts, and on each new chain that wants to use us, people have to stake on that new chain. And that splits our security thin as we split our stakes among each of those chains. And then there's also dependency on token bridges and the risks that come with each different implementation of those. So with Teller Layer, we've concentrated our security on this one L1, where all data is secured, created, validated. And we've done all this while still remaining trustless, incredibly neutral. And so I like to say that everyone in this room is in a unique position to build amazing new protocols with this great new medium tool of crypto economics, state machines. And if you are building a protocol that depends on external data, I'd welcome you to check out the Teller Oracle as a solution. And you can join the Teller Discord to join in on the discussion. Are there any questions?
So you mentioned in the case of a 2/3 attack, you can regain consensus on the Teller layer by social consensus. Right. But downstream of that, the consumers of all the Teller oracles will have already kind of been in trouble, no? So like the time to reach social consensus, like how do you imagine that process, like in like an example?
Yeah, that kind of creates a bit of you might need another waiting period then if you really want to guard against that. Or one of the proposals, like I mentioned, that there's people looking into this problem. One proposal is to implement social recovery at all layers. So, yeah, which is a big ask, but that's the only solution that I've thought of so far. And I didn't think of it myself, but yeah. Yeah.
Hello. Before it gets to that, some of the backstops that we have in place, it's basically the fact that we don't allow more than 5% of the staked amount to be transferred into the chain, and then also more than 5% of the weight of the validators to be changed within 12 hours. So if somebody was trying to switch or take over the chain, that would be one way that we would sort of know in advance. Not sure that we could stop it completely, but that would be one way that we could start thinking about that. And it would just take a long time, and also to take over 2/3 of the staked TRB or the staked amounts, it's pretty expensive because then you're going to lose it.
No more questions? No. Good. Thank you.